Hello, everyone. Welcome to our presentation. Thank you for watching our video. Our group name is the Expendables, and our project name is the Search and Destroy project using the Xbox Kinect. My name is Benjamin Ceron, and my group members are Ishita Bose, Aaron Garofano, Garrett Leach, and Ivan Rush. Our GTA is Tayo, and we just like to thank you, Dr. Vela, for teaching us computer vision. And our problem statement, our goal is to develop an application in MATLAB that uses the Xbox Kinect's color and depth cameras, two servo motors, and a Nerf dart turret to detect and track a person moving within a specified region and command the turret to fire a projectile and hit the target. And so we'll have a embed microcontroller that will be controlling the servo, and the turret is going to be mounted on top of that servo motor. And basically, a laser pointer is going to be also be mounted on top of this turret, and will be aiming at the detected target, the target detected by the Kinect, and will send feedback position values to our algorithm, which will then readjust the position as needed. So some of the background information before we get into the more technical details. For those of you who do not know, the Xbox Kinect has two cameras. It has an RGB color camera and an infrared depth camera. And it is also easily compatible with MATLAB, which is what we've been programming our algorithm in. A servo motor is a small electrical motor that is able to tilt and pan and move anything that's going to be mounted on top of it. And it receives an electrical signal, and that's how it moves its components. And it's also able to correct its positioning using some feedback loops. And a real-world example of our project is the Samsung SGR A1 Robot Sentry. It uses concepts very similar to what we're doing in that it detects a target using a camera and is able to shoot at this target. And it's actually currently in use in a demilitarized zone in South Korea. And so some of our calibration application process flow, you can see here that there are two block diagrams. And the first block diagram is the block diagram for the calibration of the Kinect and their servo turret system. And the bottom one is the block diagram for the algorithm as it is going to work in real time. And so the first block diagram on the top, the arrows represent data that we're going to be sending. So the first arrow is an input, and the blocks are algorithms. So as you can see in the first block diagram, we'll be sending as input into the system some color and depth pictures of a checkerboard. Of course, a checkerboard is used to calibrate a camera. And so once our routine in MATLAB finds these checkerboard pictures, it's going to run a calibration routine and spit out some extrinsic and intrinsic parameters that will then be used to basically translate camera coordinates to world coordinates, which we're going to need to use in order to adjust our servo. And so once it has these extrinsic and intrinsic parameters, it's going to send that data into a calibration routine for the servos. And this is going to be this side on the right side is going to be controlled by the embed controller. And so we're going to have a routine in which we will have a laser pointer mounted on top of the servo. And we will tilt and pan this laser pointer until we're able to detect where this laser pointer is at the edges of the Kinect's field of view. And once we find these maximum and minimum positions, we'll call that our boundaries, and then scale for any position in between. And so once we have these position scales, we're going to generate a scaling equation for world coordinates to servo positions in order for the servo to move accurately and accordingly. The bottom block diagram is as I said before, the block diagram for when this process is actually running and when the algorithm is actually detecting and shooting at a person. And so we're going to be sending live video data into our algorithm, and we're going to have a subroutine which is going to be able to convert this live feed and into frames that are easily processable by MATLAB. And so once MATLAB has these frames that it can work on, it's going to set up an entrance region. It's going to perform background subtraction using Gaussian mixture models, and it's going to do some detection and tracking on the target. Once it finds its target and tracks it, it's going to send these camera coordinates to another routine, which is going to translate the camera coordinates to the world coordinates. And then once it has these world coordinates, it'll send those world coordinates from the MATLAB on a PC through a USB cable to an mbed microcontroller. And once this mbed microcontroller finds these world coordinates, it itself will translate these to servo position coordinates, and it will move the servo accordingly. And of course, if you remember, the servo has the turret mounted on top, so the turret will also be moving as well. And once the turret is moving and hopefully aimed at the target, it's also going to have a laser pointer, which is going to be pointing at the target or whatever else it's pointed at. And we will have a feedback loop, which is represented by this arrow going back. And the Kinect will also be on the lookout for this laser pointer once it's moving. And it's going to detect whether that laser pointer is indeed aligned with the target. And if not, it's going to go back through the entire process and try to readjust the servo through the embed. But once it is aimed up correctly at the target, it is going to send a fire command to the turret, and that turret is going to fire a projectile. So moving on, the steps that we have explored in our entire project, one of them is the Kinect calibration. So what we've been able to do is print out a large checkerboard that we're able to take many pictures with and send those through our calibration routine. We've taken a bunch of color and depth pictures, and we've sent those pictures through the routine. However, as of now, we've only been able to retrieve intrinsic parameters. We've actually been dealing with several problems finding the extrinsic parameters. We've been dealing with errors that come up through the program that we've been using. And so that is definitely something that we'll be working on to try to find a solution to and find the extrinsic parameters as soon as possible in order so we can calibrate the depth camera. But as you can see below, the image shown at the bottom of the slide is our intrinsic parameters that we've set up. The second field that we've definitely explored a lot into is the actual image processing. And so what we've been able to do is we're able to play pre-recorded Kinect videos onto MATLAB, which of course is a good beginning. And afterwards, we have been able to successfully perform background subtraction on this video using Gaussian mixed models. So we're able to separate the foreground from the background and only focus on the foreground's data. We've also been able to set an entrance region. And for those of you who do not know, an entrance region is simply a set-aside area in the video where the algorithm is going to be focusing on that area only to detect movement and to track that person. So we've been able to do that, and the background subtraction is working inside that entrance region only. We've been able to detect the person using Gaussian mixed models and blob analysis, and we've also been able to track that target and predict the target's motion using a Kalman filter algorithm. And along with the tracking, we've been able to place a box around the person and a label around that target as well. So there's a little screenshot from one of our videos where you can see our group mate Garrett, and he has been detected and tracked. And the red box is our entrance region, and the yellow box is his own little tracking box. So I'd like to show some quick videos of what we've been able to accomplish. This is one that shows some of the background subtraction. And so in a few seconds, one of our group mates will walk into the camera frame, and you'll be able to see that background subtraction is being performed. You can see that the rest of the background is blacked out, and only a white image was shown. And if you caught it, there was also a yellow box around them, which shows that we were able to track the person. The second video that I'd like to show is from the screenshot that was shown above. Whoa. And so Garrett enters the red box entrance region and is tracked. And the yellow box is his own label and his own tracking right there. So what are our remaining steps? Our remaining steps are we need to, as I mentioned above, we needed to calibrate the depth camera and alone. So we've already calibrated the color camera, and now the depth camera needs to be calibrated. And we need to retrieve these extrinsic parameters. This is needed so that we can, again, translate the camera coordinates to the world coordinates. We also need to be able to overlay the depth data on top of color video data. And we also need to be able to program the embed so that's able to accurately control the servo and the turret once it receives world coordinates. We need to calibrate the servo and turret range using the laser pointer process that we described before, and find where those maximum and minimum boundary points are. We need to be able to successfully send world coordinates to the embed through the USB, and also create our feedback loop on the turret and the servo so that the Kinect is able to detect the laser pointer and then readjust the servo accordingly. And finally, we need to come up with a protocol that's going to fire our turret. And whether this means that the turret is going to fire its projectile upon user input, like a button press, or whether it's going to have some kind of countdown, or whether it's going to try to fire at the target once it immediately finds it. And some of the things that we've been learning, well, we've learned how to do background subtraction using Gaussian mixture models. We found a good algorithm and have explored how to use that. We've been able to track a person and predict their motion using a Kalman filter. We've learned what it means to create an entrance region and calibrate the Kinect, at least the color camera so far, and work with the depth and color image data. And we've been able to add the depth data to the background subtraction video. And that is our presentation. Thank you for listening, and hope you have a good day.